Hello everyone. Today we are going to be going through how to solve some circular functions, specifically when we have our domain defined. Now, a lot of people do like to use a more intuitive approach when it comes to questions like these, but when the domain isn't as nice as this one, so for example, you might have a domain like negative pi to 5 pi on 6. When you have a more complicated domain, it's best to use a technique where you first adjust the domain. So let me demonstrate over here. Now, note that for this equation, if this equation was simply sine of x equals a half for this same domain, this would be a lot easier to solve, right? So what we want to do is we want to try and convert this more complex equation into something that looks like this simple sine of x equals a half equation. The way that we can do this is by making our values in the brackets equal to theta. So if I make 2x plus pi on 3 equal theta, then I can rewrite this equation over here as sine theta equals a half. And again, this becomes much easier to solve. Now, I can't keep using this domain for x if I'm converting this entire equation to terms of theta. So if I'm converting this equation into terms of theta, then my domain must also be in terms of theta. So what we have to do is we have to first adjust our domain. Now, if we had just sine of x in our equation, so we only had x within these brackets, then our domain would be from 0 to 2 pi as it was defined before. However, we're not just dealing with this x, we're dealing with some translations that have been done to this x. So if our x has been multiplied by 2, our domain also needs to be multiplied by 2. If our x has had pi on 3 added to it, our domain must also be adjusted to have pi on 3 added to it. So if we only have x, we know that our domain would be between 0 and 2 pi, but we know that these values within the brackets have undergone some translations. So let's break this up one by one. It has been multiplied by 2, so if our term in the brackets becomes 2x, if our x value is multiplied by 2, then so must our domain. So our domain, if we're multiplying our x values by 2, this would adjust to 0 times 2, which is just 0, and this would adjust to 2 pi times 2, which is 4 pi. Again, we've also had a translation of pi on 3. So if our x values have had pi on 3 added to them, then so must our domains. So if we are adding pi on 3 to our x values, which were previously multiplied by 2, then so must our domain have pi on 3 added to them. So this would just become 0 plus pi on 3, which is just pi on 3. And this would become 4 pi plus pi on 3, which can be written as 13 pi on 3. Now remember at the start, we defined theta as being equal to 2x plus pi on 3. And this is exactly what we've done here. So we've turned this x at the beginning to theta by making the transformation adjustments. So we can rewrite this domain in terms of theta and write it as pi on 3 theta to 13 pi on 3. This means that we can now solve our equation, which was previously sine of 2x plus pi on 3 equals a half. We can first write this as sine theta equals a half, and we can use our adjusted domain to guide our solution. So we know that theta will be between pi on 3 and 13 pi on 3. If we just solve this part of the equation for theta, theta would equal sine inverse of a half, and using our exact values and our reference angles, we know that this would equal pi on 6 or 5 pi on 6. This is just using our reference angles, remembering that if we want to find more solutions to this equation, all we have to do is add or subtract 2 pi. But before we find further solutions, let's first check whether these two values are within our given domain of theta. Now we can clearly see that pi on 6 is smaller than pi on 3, So it is outside of our domain for theta. So this will clearly not be a solution that we're working with. However, we can use this reference angle of pi on 6 to find more solutions by adding 2 pi. So if we go our reference angle of pi on 6 plus 2 pi, this would equal 13 pi on 6, which would be your next solution. Again, 5 pi on 6 and 13 pi on 6 are still within this domain. However, to make this a little bit easier to see, we can rewrite this upper limit of our domain with a denominator of 6, just to make these numbers more easily comparable. So your 13 pi over 3 can be written as 26 pi over 6. Now, adjusting that, we can clearly see that 5 pi on 6 and 13 pi on 6 are still within our domain for theta. If we continue to find more solutions, we can add 2 pi to our other reference angle of 5 pi on 6. So if we do that, we get 5 pi on 6 plus 2 pi, which would equal 17 pi on 6. As we can see, 17 pi on 6 is less than 26 pi on 6, meaning that we're still within our domain. This means that we are going to continue to find some more solutions. Now, what we can do is we can add 2 pi to this solution here. Adding 2 pi to 13 pi on 6 is essentially the same thing as adding 4 pi to pi over 6, adding 4 pi to our reference angle. And if we go back and look at our unit circle, we know that if we have a reference angle and we add 2 pi, so one rotation or any multiple of that rotation, so say we do it twice, we've gone around and rotated 4 pi radians, we still end up back at the same spot. So what we can do is we can add 2 pi to our 13 pi on 6 to get our next solutions. So if we do that, we'll get 13 pi on 6 plus 2 pi, which would equal 13 pi on 6 plus 12 pi on 6, which would equal 25 pi on 6. That would be your next solution. 25 pi on 6, again checking that we're still within our domain. So 25 pi on 6 is less than 26 pi on 6, meaning that we are still working within our domain for theta. Now we could also find another solution and add 2 pi to our 17 pi on 6, but we can already see that we're quite close to the upper limit of our domain. And if we were to add 2 pi to our 17 pi on 6, then we would get a value which is much larger than the upper limit of our domain. So the solutions that we've found for theta are 5 pi on 6, 13 pi on 6, 17 pi on 6, and 25 pi on 6. Now, once again, we have to remember that we made this substitution for theta at the beginning. So we are asked in this question to solve for x. In order to do that, we have to put the substitution back in here. So we will have to replace this theta with 2x plus pi on 3 equals theta and solve this for x. Now we know that we have 4 different solutions for theta, so we will have to substitute each of these values into this equation one by one to determine our 4 solutions for x. Okay, let's go through this together. So our first equation would be 2x plus pi on 3 equals 5 pi on 6. Rearranging this equation, we will get 2x equals 5 pi on 6 minus pi on 3. Our pi on 3 can be rewritten as 2 pi over 6. And if we group this side of the equation, if we group these terms together, we would get 3 pi over 6, which can be simplified to pi over 2. Again, rearranging this further, if we divide both sides by 2, we would get x equals pi on 4. So this is your first solution for x. Now we are going to do the exact same thing, but for 13 pi on 6. So we would get 2x plus pi on 3 equals 13 pi on 6. Again, rearranging, we would get 2x equals 13 pi on 6 minus pi on 3, which can be written as 2 pi on 6. So 2x would equal 11 pi on 6. Dividing both sides by 2, we would get x equals 11 pi on 12. So here is your second solution for x. Now we will do the same thing for 17 pi on 6. So we would get 2x plus pi on 3 equals 17 pi on 6. Again, rearranging, we will get 2x equals 17 pi on 6 minus 2 pi on 6, which is the same thing as pi on 3. And so 2x would equal 15 pi on 6. And dividing both sides by 2, we would get x equals 15 pi on 12. Now this can be simplified to x equals 5 pi on 4. So here is our third solution for x. Last one, we are now dealing with 25 pi over 6. So again, we would have 2x plus pi on 3 equals 25 pi over 6. Rearranging this, we would get 2x equals 25 pi over 6 minus 2 pi on 6. This would equal 2x equals 23 pi on 6. And dividing both sides by 2, we would get x equals 23 pi on 12. So this is your fourth solution for x. So let's write all of these solutions together. So we have x equals pi on 4, x equals 11 pi on 12, x equals 5 pi on 4, and x equals 23 pi on 12. So here are your 4 solutions to the above equation that we determined by first adjusting our domain and replacing the 2x plus pi on 3 with theta. As always, let me know if you have any questions. Otherwise, I will see you guys next time.